All right. This is part 3 of 3 on a series of videos about linear equations. The last video left off as we were talking about what slope is. Knowing the slope of a line is important, but if all we know is the slope of a line, then we can't tell what the graph will look like. We can see here the slope of this line. Here's a point, right? That's when x is 1, and when x is 2, we can clearly see that when we went over 1, we went up 3. So the slope of this line is 3. However, we could just as easily take this line with a slope of 3 and move it anywhere, right? Let me get rid of that little thing. We could just as easily move this anywhere. This line still has a slope of 3 no matter where it is, right? That's still a slope of 3. That's still a slope of 3. That's still a slope of 3. So knowing the slope tells us how steep that line is moving up or down, but what it doesn't tell us is it does not tell us where that line is located, right? Any of these points have a slope of 3 over 1. Vice versa, we can't tell exactly what an equation is going to look like just based on the graph. We know that this is going to be, let me get my pen back. We know that this is going to be y is 3x. Because every time x goes up 1, y has to be 3 times bigger than that. That's 3 times bigger than this is the output. Y is always 3 times bigger than the input. But once again, that doesn't tell us where this is going to be, right? Under this presumption right here, if x were 0, y would be 0. But clearly, this line does not go through here. So something is missing. And I hope you can kind of sense that there's some other piece of information that we need to be able to accurately graph where a line goes. Since we know that the change in y will always be 3 times the change in x, we know the equation starts with y equals 3x. Looking at the graph, we can see that when x is 0, y equals negative 4. So we have to ask ourselves, what could we do to this equation? What could we include in this equation so that when x is 0, y is negative 4? 3 times 0, and then something else equals negative 4. What has to go here? Something is missing. And I'll give you, pause, think about it. That's a great question. When we say, what could we add to y equals 3x so that when x is 0, y equals negative 4? Well, 0 plus what equals negative 4? Well, 0 plus negative 4, right? So now when we write this equation as y equals 3x, and instead of saying plus negative 4, I'm just going to say minus 4, because plus negative 4 is the same thing as minus 4. Now what this says is, hey, you need a line so that every time x increases by 1, y increases by 3. That's what this does. And, right, plus, and when x is 0, y still needs to be negative 4. When x is 0, negative 1, negative 2, negative 3, when x is 0, y is negative 4. This now fixes this line in one place on our graph. This is called the y-intercept. This minus 4, negative 4, is the y-intercept. It's where this line crosses the y-axis. And you could try it without changing the slope. There is no way to move this line anywhere and it still go through negative 4 on the y-axis and have that same slope. There's no way to move this line around. We now know exactly what this line is going to look like. When we know the slope and the y-intercept, we can draw any graph from any equation, and vice versa. We could write any equation from any graph. That's what we just did. We said, what's the equation of this? And initially, that may seem really scary to just be like, here's a line, write an equation. But we say, okay, well, what do we know? We know that y is always going to be 3 times bigger than x. We know that the output, the change in x, is always going to be, or I should say the change in y is always going to be 3 times the change in x. And we know that it crosses the y-axis, that when x is 0, y is going to be negative 4. And now we've created an equation. That's it. We're done. That's linear algebra. Congratulations. That's it. So now let's take a look at some lines. Let's practice this a little bit, okay? What's the slope of this? Well, let's take a look here. Here's a point. And here's a point. When x went over 1, how much did y change? Well, it went up 2, positive 2. So 2 over 1, which is the same thing as just saying 2. And what's the y-intercept? Well, I just pointed that out, right? When x is 0, if that's 0, that must be negative 1. So this equation is y is 2 times as big as x minus 1. We're done. That's easy. Let's take a look at this, right? Oh, I didn't mean to leave the line here. Hold on. I give you an equation, and I want you to draw the line. Sorry. So let's take a look at this. What's my slope? Well, y is always going to be negative 2/3 the size of x plus 4. So when x is 0, negative 2/3 times 0 is just 0. So when x is 0, my line is at 4. So let's go ahead and do that. When x is 0, 1, 2, 3, 4. Right? If you put 0 in, negative 2/3 times 0, that becomes 0. Plus 4, y must be 4 when x is 0. Now, y is always negative 2/3 of x. So that means every time x goes over 3, y will have gone down since this is negative 2. So let's go over 3, 1, 2, 3, and down 2. And now with 2 points, I can connect my line if I wasn't terrible at drawing. And we're done. We've made a graph from an equation. We can also do the same thing from the slope. From a table, right? Negative 2 to negative 1. That means when x goes over 1, y, what happened? 4 to 1, that's minus 3. So my slope, y went down 3 when x went over 1. So my slope is negative 3. And my y-intercept, right? When x is 0, well, it tells us. When x is 0, y is negative 2. So y is going to be negative 3 times the size of x minus 2. And we're done. We can also graph this, right? Negative 3, y-intercept negative 2. So when x is 0, y is negative 2. And my slope says every time x goes over 1, I should go down 3. And now I'm done. I've created this linear equation. I've created a graph from a table from a equation. So the last part of this, what I want to give you, is here's a problem. Here's a line, and it's on a graph. And I want you to tell me the slope of this line and the y-intercept. I want you to tell me what the equation of the line is, and explain what slope and y-intercept mean. Just in your own words. I want to know what you think that means. Give me an example. Put in your words. How do these two things play together that enable us to graph equations and as a result solve problems in life? Thank you.